Hello, my name is Murilo, and this is my presentation for the final project for the class Programming with C. Um, so I prepared this presentation to give an insight of what we did. So our project was about solving two scripts that will solve second order linear equations, and they will be in this format shown right here, where D will be the derivative of y in terms of with respect to time. A1 and A2 are two constants, and how the results for these equations will be, it would depend on the roots for the quadratic equation, and if the roots are real and non-repeating, they will print this type of result. If the roots are real and repeating, the natural response will be in this format, and if the roots are complex, the result will be in this format. So for my first script, I started the script prompting the values of A1, A2, and the initial conditions for the equations, so I can use them to calculate the values of C1 and C2, which are these values right here. And the next step, I created a function to calculate the roots, and they will have different equations depending on if the roots are non-repeating, repeating, or complex. And these are the equations that I used, which is basically the quadratic equation. And if the roots are repeating, I wouldn't have to do all this, just this is enough. And if the roots are complex, I'll have to calculate the alpha and the beta, which is the real and the imaginary part. And after that, I use the values of A1, A2, Y0, and Y prime of 0 to calculate the constants. And if the roots are repeating and real, this will be the equation necessary. And it will basically just be a matrix with two variables. If the roots are repeating, these are the equations. A matrix wasn't required for this. And if the roots are complex, the process is a little different. I ran some equations before doing the program, and I found that the best way to do it is to calculate C this way and calculate the values, the value of the angle using this formula. The second approach was very similar, but it has some differences. So the first difference is that I didn't have to prompt any numbers, and I barely used any equations, just some to calculate C1, C2, and theta. And I used these tools to open a file, read the values inside a file, and print the results in a different file. And how the results will be, and they will be different from script 1, since the script 1 will print the natural response on the terminal. For this script, we'll print the result in 3 columns. The first column will contain either 1, 2, or 3, and it will print 1 if the roots will be non-repeating, 2 if the roots are repeating, and 3 if the roots are complex. In column 2, it will print the values of the constants if the roots are repeating or non-repeating, and in column 3, it will print the values of C and theta. So my learning experience with this project was that I got a better understanding on how to use header files and implement them in my main script. I had some challenges with it before. I also had I was very confused on how to use user-defined functions, but this project helped me realize how to organize them better and put them in my main file later. And it also gave me a much better understanding on open, reading and writing values from files on the compiler. So some challenges that I faced with this project were that for script 1 was getting the equations that I showed before. In here I wasn't really sure how to get the values of C1 and C2, so I thought that using the matrix way to do it would be a very efficient way. And also these values I had to do some calculations before reaching the solution. And for script 2 I was very confused and lost on how to open files, use the new fscanf and fprintf, but I was able to figure it out and get it to work on the compiler. My project opinion for this project is that I really enjoy writing the scripts because it combined everything that we learned for this class into one main project. And some of the modules that we learned through the semester were the printf, the math.h for math functions. I use this a lot. If-else statements to get different values depending on some conditions. And scanf to scan the values printed, header files, and work with files like txt. Now I'll demonstrate my code working and with some examples that I saw in the file. So this is the header file for script 1. This is a function to run the roots if they're non-repeating and real, repeating and complex. And I call it again using this function, and this function will be responsible for printing the responses with the values of the constants, or the constant and the angle if the roots are complex. And I will call them again in this main function with the values prompt for a1, a2, y0, and y1, which is y prime of 0. So I separated this file also with some examples. So the first example, we print non-repeating roots, and if you run it, it asks us to prompt. So 3, 2, 0, -5. As you can see, this also prints the equation, the roots calculated, and the natural response if the roots are not repeating. So this is the value of C1, R1, which is here, C2, and R2. Now we can check that in the file that, if the roots are not repeating and real, this will be the format, which is exactly what it shows here. Now if we check for repeating roots, I'll use these numbers, which is 6, 9, 3, -7. So 6, 9, 3, and -7. You can see there's only one row because they're repeating. And this is the natural response for it. This is the value of C1, C2, and the only root. And if you check in the code, if the roots are repeating, we print in this format, which is what it shows in here. Now if we do the same for now a complex root, I'll have to use these values, so 4, 42, and 16.78. So 4, 42, 16.78, and it'll give me complex roots, and the natural response for it, this is the value of C, this is the real root, which is this, the complex root, and the value of the angle, which is 60 degrees. And if we check in here, if the roots are complex, it will give this type of format for the natural response, and that's what we have here. Now for script 2, it's very similar as the presentation show. Non-repeating roots repeating 1, repeating roots repeating 2, and complex roots repeating 3 on the first column of these file here. And if the roots are non-repeating, we're printing C1 and C2. The same for repeating roots, and for complex roots, we're putting column 3 instead with the values of C and theta. And now we don't have to prompt values of these 4 constants. I will just read them from this file. So we can run the same examples and see if the results are the same. So the first one was 3, 2, 0, and -5. So save. And this file right here, this is the value of A1, A2, Y0, and Y prime of 0. So this code will read them in order and print the results in this file as I programmed it. So if you run, we can see then here in the first column we printed 1 because they're non-repeating roots, and these are the values of C1 and C2. And in third column it didn't print anything, or it just printed 0 because the roots are not complex, so there's no value of just C or the theta. Now if we change these to 6, 9, 6, 9, 3, and -7, we're gonna see some changes in this file if we run here. As you can see, the first column printed 2 because they're repeating rows, and these are the values of C1 and C2. And again, it didn't print anything on the third column because the roots are not complex. Now if we change this to 4, 42, and 16.78, the values will change in the result.txt. Now it shows 3 because the roots are complex. We show 0, 0 on the second column because the roots are complex, so the values of C and the angle shown in column 3 now. So this was my final project for the class Programming with C. I hope you enjoyed this presentation, and I'll see you later.